In this video, we are going to discuss solutions to previous year questions of engineering service examination. Let us start with ESE prelims 2017. The question is solution of the system of equations x plus y plus z is equal to 4, x minus y plus z is equal to 0 and 2x plus y plus z is equal to 5. We need to find out what is the suitable x, y, z that satisfies these three equations. We have been given four options. In these kind of questions where we need to find out values of x, y, z, it is always, particularly during the competitive examinations, it is always better to substitute the given options into the given equations and then find out which actually satisfies the given set of equations. In this case, option A 2, 2, 0, option B 1, 4, 1, option C 2, 4, 3, option D 1, 2, 1. If you check properly, option D is the one which would actually satisfy the given set of equations. 1, 2, 1, 1 plus 2 plus 1 is 4. 1 minus 2 plus 1 minus 1 plus 1 is 0. 2 into 1 2 plus 2 4 plus z is 1 5. So it satisfies all the three equations. So this would be the correct option. However, just to cross check, if you take option A 2 2 0, 2 plus 2 plus 0 4, it satisfies. 2 minus 2 plus 0 is equal to 0, it satisfies second equation also. 2 into 2 4 plus 2 6 plus z is 0. This LHS is 6, RH is 5. So option A does not satisfy third equation, whereas option B 1 4 1, 1 plus 4 plus 1 is 6, so it is not satisfying. And option C is 2 plus 4 plus 3 is not equal to 4, so this is also wrong option. Now let's see the next question. The complete integral of z minus px minus qy whole cube is equal to pq plus 2 into p square plus q whole square is, four options namely a, b, c, d were given. Okay. Now before proceeding to solve any equation, the moment a question is given, what you need to do first is it directly relates to any standard form that we know. By first seeing this question, what you should get thought is there is terms like px, qy in the given equation, and on the right side we have a complete two terms. The complete RHS is only consisting of only p and q. In the first place, the given question, by seeing this, you know that this is solution of partial differential equations. From that chapter it was given. P is nothing but dou z by dou x and q is nothing but dou z by dou y. So now, in the solution of partial differential equations, if you recollect, by observing these terms, particularly px, qy and a complete function, some function of pq, where it will come? We know one standard form where if the given form is z is equal to px plus qy plus some function of p comma q. This is a standard form in solution of partial differential equations. This we have seen already. So the given equation also has the same terms, px, it has qy, it has some function of pq, it has. But the given function is not exactly in this form. So try to rearrange the given function in the known standard forms what you know. Now if I have to rearrange this I can write it as, here it is cube is there, so you keep send on the other side, or take cube root on both the sides. This will become z minus px minus qy is equal to, if I take cube root on both the sides, cube root and cube gets cancels, on the other side it becomes cube root of the whole expression, pq plus 2 into p square plus q whole square. Now you send px and qy on the RHS side. So this becomes minus px and minus qy. When it goes to RHS, it becomes plus px and plus qy. So this whole equation becomes z is equal to px plus qy plus cube root of this expression. cube root of pq plus 2 into p square plus q whole square. Now if you compare these two terms, this is exactly in this form. Z is equal to px plus qy plus some function of pq. So now it is in this form. Now recollect the theory what you have read already. If a given equation, given partial differential equation is of this form, z is equal to px plus qy plus f of pq. So what is the solution of these kind of an equations? The solution is z is equal to simply replace p comma q with two new different constants, say suppose a and b. So the given equation p, replace p with a, replace q with b, a and b are two different constants, and just rewrite the whole equation. That would be the solution. So it becomes z is equal to px, you replace p with a, ax, plus qy, you replace q with b, by, plus f of a comma, in place of p you write a, in place of q you write b. So the solution for this is z is equal to ax plus by plus f of ab. So from this, what would be the solution of this? Solution of this given equation? Solution will be z is equal to, in place of p you need to write a, so ax, in place of q you need to write b, by plus cube root of ab, in place of pq you need to write ab, plus 2 into, in place of p, a square plus b whole square. So this is the solution for the given problem. Now check options which exactly matches with that. If you see the first option, in place of the f of pq has not changed, so this is not correct. F of pq has written wrongly, so this is not correct. Z does not match, this is also wrong. So the correct option is option B, it exactly matches. ax plus by plus cube root ab plus 2 into a square plus b whole square. So the important thing is, if a given problem is given, for any given problem, what you should do is, mostly in engineering services examinations, what happens is, he will not ask you very typical or very difficult questions. What he will ask is, mostly he will give from the theory directly. So what you should know is where it exactly falls, what standard form it exactly resembles. So you try to guess that form and then you can directly guess the answer. So the correct option here is B. Now let's see the next question. The minimum value of function f of x is equal to x cube by 3 minus x occurs at x is equal to 1, minus 1, 0 or 1 by root 3. By seeing the given question itself, we know this is a maxima minima problem. Okay, all maxima minima problems can be solved in two methods. The first one, what we know is by applying the theory what we know. The second one is by substituting the given options. Now let us solve it by the theory what we know. Okay, we know from the maxima minima theory, at maxima or minima, for any function, the first derivative shall be equal to 0. So, first derivative shall be equal to 0 at maxima or minima. Now, at a point x, if first derivative is equal to 0, there maxima or minima will exist. Now, how we know the point is whether it is maxima or it is minimum? That we will know by using the nature of the second derivative of that function. If the second derivative you found out at that point and it is greater than 0, then the point corresponds to minima of that function. If the second derivative is less than 0, then the point corresponds to maxima of that function. Okay, so this is the theory we know. At maxima or minima, the first derivative of a given function will be 0 and the second derivative will be less than 0 at minima, at maxima, greater than 0 at minima. This is the theory we know. So to apply this, we should have found out f dash of x and f double dash of x. Now, for the given function, you first write what is first derivative. Given function is x cube by 3 minus x. If you differentiate with respect to x, differentiation of x cube is 3 3x square by 3 minus differentiation of x is 1. The standard differentiation formula d by dx of x power n is n into x power n minus 1. Since the given two terms are in the form of x power n, I have used this formula. The x cube derivative will be, in place of n, 3 is there, so it becomes 3 into x power 3 minus 1, that is 2. So 3 into x square. X is, in place of n, 1 is there. So 1 into x power 1 minus 1, 0, that is nothing but 1. So the derivation is 1. So 3x square by 3 minus 1 is nothing but x square minus 1. Now what is the second derivative? Again differentiate f dash of x with respect to x. So x square derivative is from this 2x minus 1 is constant, so differentiation of that with respect to x will be 0, so we don't need to write anything. So this is the first derivative of the given function and this is the second derivative of the given function. We know at maxima or minima the first derivative shall be equal to 0. So now make this equal to 0 to find out at which point this will be equal to 0. So by making f dash of x is equal to 0, that means x square minus 1 is equal to 0. That is x square is equal to 1. That means x is equal to plus or minus 1. So we have two values for x is equal to plus 1 and x is equal to minus 1, at which either maxima or minima will occur. Now what we want? Minima. At minima, what is the condition? F double dash of x shall be greater than 0. Out of two values for x, we have x is equal to 1 and x is equal to minus 1. F double dash of x is 2 into x. So we have two values for x. X is equal to 1 and x is equal to minus 1. Out of these two, at which f dash of x will be greater than 0? When x is equal to 1, it becomes 2 into 1, 2, it will be greater than 0. So at x is equal to 1, f double dash of x is greater than 0, so there minima will occur. So the option here is option A. Now this is by applying the theory we know. Now how to find out? Sometimes if the given function is very simple function and options are also simple, then you can actually directly substitute and find out what is the correct option. Okay. That way also let us just solve this equation once quickly by substitution. Okay, I'll just erase this here. Okay, I'll write it here. By substitution. Okay, this method will work. You can go ahead when the given function is simple. Okay, let us just substitute all the four options. If you substitute 1, it becomes 1 cube by 3, that is 1 by 3 minus 1. 1 by 3 minus 1 is 1 by 3 minus 1 is 1 minus 3 by 3 minus 2 by 3. So the first after substituting the first option, the value I have got is minus 2 by 3. Substitute the second option, x is equal to minus 1. It becomes minus 1 whole cube by 3 minus of minus 1. That is minus 1 whole cube is minus 1. Minus of minus 1 is plus 1. 1 minus 1 by 3. So the second option gives me 2 by 3. Now substitute third option 0. It is 0 cube 0 0. So the value that I have got is 0 by substituting option 3. Option C. Now by substituting 1 by root 3. This is not a straight integer value. It is slightly tricky value. However, let us just substitute and see how we can actually arrive at the correct option. Now substitute 1 by root 3. It becomes the given equation. If we substitute 1 by root 3, it becomes 1 by root 3 whole cube by 3 minus 1 by root 3. 1 by root 3 whole cube is 1 by root 3 into root 3 into root 3, that is nothing but 3 root 3. So 1 by 3 root 3 by 3, that is 1 by 3 root 3 into 3 is 9 root 3 minus 1 by root 3. Okay, if you find out the result is, if I make denominators equal, it becomes 9 by 9. 9 by 1 by root 3, I can write it as 9 by 9 root 3. So 1 minus 9 minus 8 by 9 root 3. So the fourth option gave me minus 8 by 9 root 3. So the question is about minimum value of the given function. So these two are positive numbers, these two are negative numbers. So certainly positive numbers cannot be the minimum here because negatives are there. So this is not a correct option and this is not a correct option. Now we are left with two options. Okay, so we need to compare these two to find out what is the minimum. To compare two fractions, what is the easiest way to compare? Either make the denominators equal or make the numerators equal first, then you compare them, you can easily compare. So in this case, let us make the denominators equal first. Here 3 is there, here 9 root 3 is there. So if I come, so I am left with, I am writing it again here so that it is easy. So we are left with option A and D. Option A gave me minus 2 by 3, whereas option D gave me, option A gave me minus 2 by 3, option D gave me minus 8 by 9 root 3. To compare, let me make the denominators equal. To make these two equal, I have to multiply this by 3 root 3. So that here also 9 root 3 will be there, here also 9 root 3 will be there. Now, since the denominators are same, in the numerators whichever is lesser, that will give me the least among these two. So, to make the fraction same, to maintain the fraction same, multiply with 3 root 3 on both the sides, both to the numerator and to the denominator. So, this value becomes minus 2 3s are 6. So, minus 6 root 3 by 9 root 3. This becomes minus 8, the same, minus 8 by 9 root 3. So denominators are same now. Comparing the numerators, root 3 is nothing but 1.732. So approximately 1.7 if you take, 1.7 into 6 is around 10.2. 6 7s are 42. So 10.2. This is minus 10.2 by 9 root 3. This is minus 8 by 9 root 3. Out of these two, whichever is the highest negative number, this is the high negative number. So the total value will be smaller compared to these two. Comparing these two, this will be the smaller. So option A will give you the minimum value. Similarly, if you make the numerators equal, how it will turn out? We were left with, okay, I'll write it again, minus 2 by 3 minus 8 by 9 root 3. Earlier I have compared by making the denominators equal. Let me compare now making the numerators equal. So numerator, here 2 is there, here 8 is there. By multiplying this by 4, I can get this number. So multiply both denominator and numerator to maintain the same value for the fraction. So this becomes minus 8 by 12. This becomes minus 8 by 9 root 3. Okay. Now numerators are equal. Coming to the denominators, here 12 is there, here 9 root 3 is there. Root 3 is again 1.7. So 1.732 into 9, 9 7 63, 9 6 15. So 15.3. Here it is minus 8 by 12, here it is minus 8 by 15.3. So the denominator is lesser here, is more here. So lesser will give me higher total value, negativity. So higher total value will be the least value since it is negative. So this is the least value out of these two. So now again option A is the correct option. Okay. So the concept what I have used here is, suppose if you have two fractions whose denominators are same. Say suppose I have here denominator 3, I have denominator 3 here. Okay. Now if the numerator here 20 is there, here 21 is there. Okay, or otherwise here 19, 20 let me take. Here 19 is there, here 20 is there. Out of these two, which is the lower, which is higher? Since denominators are equal, whichever has lower numerator, that will be the lowest. Whichever is the higher numerator, that will be the highest value. So this is the lowest here. Similarly, if I have numerators are same, but the denominators are different. Now out of these two, which will be the low and which will be the high? When the denominator value is high, that means you are dividing 3 here with 20. Here you are dividing the same number with a lesser value. So this will become higher, this will become lower. Since denominator is higher, so the total value will be lower here. So this is the lowest value, 3 by 20. So that I have used to check, to compare these two and to arrive at the option. But when you find out minimum value, you will always have to be by method of substitution. Okay, you will always have to be a bit more cautious while finding out the correct option. Say suppose, to make your work, to understand it better, let me just introduce a new option. In place of 0 here, I have, say suppose, minus 2. Okay, if I compare all the 4 options, in place of the third option now, I'll just rewrite these 4 options. First option remains same. First option gives me minus 2 by 3. By substituting the next option, I have got 2 by 3. By substituting minus 2, what I will get? Minus 2 whole cube by 3. If I do it here, minus 2 whole cube by 3. Minus of minus 2. So this gives me minus 8 by 3. Minus of minus 2 is plus 2. So this becomes, let me do minus 3. Okay, so this becomes minus 3 cube by 3. Okay, if we substitute minus 3, it becomes minus 3 whole cube by 3 minus of minus 3. Minus 3 whole cube is minus 27 by 3, that is minus 9. This is plus 3. So the answer is minus 6. So by substituting third option, I have got minus 6. By substituting fourth option, just to not to confuse you more, let the fourth option be, say suppose, 0. Earlier it was 0, earlier it was 1 by root 3, I have just changed it to minus 3 and 0. So this gives me 0. By directly comparing all of these two, you may think, since minus 6 is the least among all the options, you may think this would be the correct. So correspondingly, option C would have to be the correct. If you go by the theory, if you go by just whatever we have done, the same rule using substitution. But actually we have seen this is the correct option. If you write this, then if you choose this, then your answer will be wrong. Now, where we went wrong? You have, in case of a maxima or minima, you cannot blindly go by whatever value you are getting by substituting all of them. You should always check whether the given x satisfies this condition or not, because at maxima or minima, the first derivative shall always be 0. At maxima or minima, the first derivative shall always be 0. The corresponding x here is minus 3. If you substitute x is equal to minus 3 in first derivative, minus 3 whole square, that is 9 minus 1 is 8, which is not equal to 0. So this can never be a correct option. So when you are solving any maxima or minima problem, not by theory but by using substitution method, you should thoroughly, after evaluating your options, you should check whether my f dash of x is 0 or not. If it is not 0, you should immediately eliminate those corresponding options. Okay, this extra precaution you need to check while solving using method of substitution.